Welcome to The Explainer. Hey, if you're gearing up for your PCI Level 1 or Level 2 certification exam, you are in the perfect spot. Seriously, think of this as your personal study guide for that crucial chapter on reinforcement and pre-stressing. We're going to cover exactly what you need to know for the test, focusing on your role as an inspector. All right, let's get right into it. So let's kick things off with a huge question, one that's really at the heart of this entire topic. We all know concrete is tough stuff, right? We build our cities out of it. So why on earth does this incredibly strong material crack when you put a heavy load on it? The answer to that question is the key to why reinforcement even exists and why your job as an inspector is so critical. To get to that answer, here's our game plan. First, we'll break down concrete's fundamental flaw. Then, we'll jump into conventional reinforcement. After that, we'll explore the power of pre-stressing. That's a really big one for you Level 2 candidates. Then we're going to get super practical with handling and fabrication rules, and we'll wrap it all up with the essential installation and inspection keys. Okay, Section 1. Concrete's fundamental flaw. Look, before we can even talk about the solutions, you have to be an expert on the problem itself. This is the why behind every single thing you're going to be inspecting out in the plant. So let's talk about what concrete does best. It is a superpower. It is absolutely fantastic in compression. Just imagine squeezing a concrete block from the top and bottom. It can take a mind-boggling amount of pressure that way. That's its strength. But every superhero has a weakness. And for concrete, it's tension. It is just terrible in tension. If you try to pull that same block apart, it'll just snap. So think about a simple beam. When you put a load on it, the top gets squeezed, that's compression, it's happy, but the bottom half gets stretched apart. And that stretching force, that's tension. And that's where unreinforced concrete fails every single time. It cracks from the bottom up. So how do we fix this fundamental flaw? Well, that brings us right into Section 2, conventional reinforcement. This is the classic solution, and it's a concept you absolutely have to master for your Level I exam. The fix is actually pretty brilliant in its simplicity. We just put steel bars, rebar, right in the areas where that tension is going to happen. For a simple beam, that's usually the bottom. The wet concrete flows around the rebar and hardens, creating this incredible bond. So now when that beam is loaded, the concrete basically hands off those stretching forces to the steel. And steel loves tension. It holds the whole thing together. Now, here is a term you absolutely positively must know for your exam. Write this down. Effective depth. It's the measurement from the dead center of the rebar all the way to the top edge of the concrete. Why is this so important for you, the inspector? Because this one little dimension has a massive, massive impact on how strong that beam is. If the rebar is placed just a little too high or a little too low, you've changed the effective depth and you could be seriously compromising the member's capacity. It's a huge deal. Okay, let's get specific about your exam. For all you Level I folks, you need to nail the basics. Why do we need reinforcement? How does regular rebar work? And the hands-on stuff, like checking bar sizes and making sure they're in the right spot according to the drawings. Now, for Level 2, you need all of that, plus the advanced topics you see on the right. Things like pre-stressing, running some basic elongation calculations, and understanding how strands are tensioned. Now, conventional rebar is great, but it has one little catch. The concrete actually has to start cracking a tiny bit before the steel really starts doing its job. That brings us to the next level, the power of pre-stressing. This is the proactive approach, and it's a core topic for all you Level 2 candidates. The easiest way to think about this is passive versus active. Conventional rebar is passive. It just sits there, kind of waiting for a problem, a crack, before it jumps into action. Pre-stressing, on the other hand, is active. It's a preemptive strike. We stretch high-strength steel strands and put the concrete into compression before it ever sees a load. So it's already squeezed together, actively fighting against the tension that's coming later. This means we can prevent cracks from ever forming in the first place. As an inspector, you're going to see two main types. The most common one in a precast plant is pre-tensioning. That's where the strands are stretched first, like giant guitar strings, and then the concrete is cast around them. Post-tensioning is different. That's where the concrete is cast with hollow tubes inside, and the strands are threaded through and tensioned after the concrete is already hard. Knowing which is totally key to your inspection. Okay, enough theory, let's get down to the nitty-gritty, the stuff you're going to be looking at on the plant floor every single day. Section 4, handling and fabrication rules. This is where big mistakes can happen long before any concrete shows up, and your job is to be the person who catches them. And it all starts with how the steel is stored. This is your first line of defense. First, steel has to be off the ground, on blocks, on racks, I don't care, just not in the dirt. You also need to make sure every bundle is tagged so you can trace it back to its mill certificate. Now let's talk about rust, a super common question. A little bit of light, flaky rust that you can wipe off, that's okay. But if you see heavy, scaly rust that's pitting the steel, that's a fail. That's cause for rejection. And of course, keep it clean. No oil, no grease, nothing that's going to mess up the bond with the concrete. Now, coated bars are special. That coating is their armor against corrosion, so your main job here is to be the guardian of that coating. This means you have to make sure crews are using padded slings or nylon straps to lift them, not standard wire ropes that will just scrape that coating right off. And if you do spot damage, your job is to make sure it gets properly repaired with the approved material before it gets buried in concrete. When the rebar cages are being built, there are a few key checkpoints. Bending should be done cold, period, unless the engineer has specifically approved heating. And when tying the bars together, the tie wire has to match, coated for coated. But here's the big one, the huge red flag, welding. Any welding on rebar requires specific approval from the engineer. And this is a safety rule you must enforce. You never, ever allow welding anywhere near those high-strength prestressing strands. All right, this brings us to the final section, and honestly, maybe the most important part of your day-to-day job, installation and inspection. This is the final check. This is your last chance to make sure everything is perfect before it's literally set in stone. Here is another vocab word for your exam that is at the center of your universe. Reinforcing bar cover. It's simple. It's just the amount of concrete between the rebar and the outside world. This isn't just for looks. This layer of concrete is what protects the steel from weather, from chemicals, from fire. It's its shield. So how much cover do you need? Well, it's not a random number. The engineer figures it out based on things like where the piece will be used or how big the aggregate is. Now, good news, your job isn't to calculate it. Your job is to take the shop drawings, look at the number, then grab a ruler and physically verify that the rebar in the form has the right amount of cover within the allowed tolerances. And that brings us to what I like to call the golden rule of being a PCI inspector. Just soak this quote in. If a bar doesn't fit, if something's in the way, you don't cut it. The crew doesn't cut it, nobody touches it. Any change, no matter how small it seems, has to have written approval from engineering. End of story. This is absolutely non-negotiable. So there you have it. We've gone through the what, the why, and the how that you'll need for your exam. But I want to leave you with one last thing to think about. This isn't just about passing a test or memorizing rules. It's about understanding what happens in the real world if these rules get ignored. A bar in the wrong place, a damaged coating, a little unauthorized cut. These aren't just minor mistakes. They can affect the safety and the lifespan of a bridge, a building, a parking garage. That's the real weight of your job. And that's why what you know and what you do is so incredibly vital.